Hi, welcome to the first video in the Code Wars C++ series. If you've been following me, you know I have a long series running already with C#. I'm going to branch out and cover some other languages. C++ here will be one of them. I haven't used the language in a couple years, but it's one that I used to use quite a bit, so you'll see me kind of shaking some of the dust off probably as we go. If you notice things that I can do better, definitely, like in the other series, hit me up in those comments, and I appreciate that. That's very helpful. But I think I can get back into the swing of it pretty quick, and if not, then we figure it out together, and there's something worthwhile about that too. So I've learned a little bit more about the Code Wars website. I'm going to start with these 8 Caillou category. I figured out that's the easiest types of problems, so this will be a beginner-friendly course. You don't have to know anything about programming to get started. And the idea is that you learn by actually following along with these challenges. It's very important that you attempt them first. Maybe not in these first few videos. If you know absolutely nothing, then it's okay just to watch me. But as we go, you're going to want to challenge yourself once you've built up a little toolbox of little ideas that you have, things you know how to do, and sort of integrate those to coming up with your own solutions. So with that said, we'll get into it. We'll talk more about the series as we go, but the spirit here is to get right into code, so let's do that. We have a challenge here. It's called quarter of the year. Given a month as an integer from 1 to 12, return to which quarter of the year it belongs as an integer number. For example, the month 2, which is February, that's part of the first quarter. Month 6, June, is part of the second quarter, and month 11, November, is part of the fourth quarter. And we can think of this, right? There's 12 months. If you divide that by 4, right, that's what a quarter is, you come out with 3. So months 1, 2, 3 are going to belong to first, 4, 5, 6 belong to 2, 7, 8, 9 belong to 3, and 10, 11, 12 would go to quarter 4. So that's what we're going to do here. We're just going to do some basic math. If you want to think about how you might do a system of that, you can pause the video now. That's what you'll normally do. Work it out and then resume when you're ready. So you may be familiar with if statements. You could check, like if this input parameter here, month, you could write if month equals 1, return 1 for first quarter, and you could do that 12 times, right? That'd be one way to do it. I'm going to try and condense it because I don't like doing very large if-else statements that are 12 long or more. It's really ugly in my opinion, so I don't like that. But if that's all you have and that's how you solve it, that's great. The thing is that you're solving problems, and you're going to see little tricks for cleaning that up. So for this, I'm going to kind of think of the quarters as blocks and then use the month number to see how many of these blocks I cover, and then round up if there's any remainder. So I'll be dividing by 3 for the input month, right? So take, for example, June. If I divide that by 3, I come out with 2 evenly, and that's in the second quarter. 4, 5, and 6 were, right? And so you can test it with all the numbers. I'll go ahead and start coding. So for this one, I'm going to take the month and I'm going to divide it by the quarter size. And a common thing we do is we don't like to use what are called magic numbers in programming. I could just put 3 here, but the problem is when I'm working with you and you come look at my code and you just kind of go, huh, why'd that guy put a 3 there? What does that 3 mean? It's not very expressive unless you happen to be very familiar with what's going on, but that's not always going to be the case. Commonly, you're going to come in to a new project, you're going to inherit some old code, there might not be anyone to even ask what it means. So we kind of break things out into constants, and then I can name it, and the value doesn't change, right? A quarter is always going to be the same number of months. That's why it's constant. It doesn't change. Regular variables can change. In this case, I'm going to use a floating type here. We'll see why in a moment. Just bear with me for now. And I'll call my constant num as a number of months per quarter. And that'd be the same as 12 divided by 3, right? I'm just going to write it out as 3. So, and because I'm using a float is floating point, which means that you can have decimal values as well. I got this decimal point, so it could be 3.25, it could be 3.719, it could be anything, as opposed to consider this int type, which is short for integer. These are whole numbers. This is 5, this is 17, this is 792, you know, they're whole values. So I'm going to use it as a float because something different happens when I run a division. If you divide with just integers, the result is an integer. It's the same type. And so what happens is if you have a decimal part, like consider if I divided 1 by 3, right, that would be 0.333. All those decimal values, those fractional values, they just get truncated. So it would just say it's 0. And that's not what I want in this case. But if I make one of the numbers a float, it'll do the calculation and preserve the fractional part that I want. So that's why I did that here. Number of months per quarter. Okay, and this isn't quite right. I actually have to round this up in case it goes over a little bit. Like I think I used the example 6 before for June, but imagine if I used the month 7, right? And then if I divided that by 3, you get 2 1/3. Clearly 7 isn't in the second quarter. We got that third left over, which actually bumps it to the third quarter. It's not covered by the second quarter. So I'm going to use a handy mathematical function that's built in. It's called a ceiling function. And what this does is it's like rounding, but the rounding you learned in school when you were a kid, right? That was kind of like if you were at 0.5 or higher, round up. And if you're below 0.5 for your fractional part, then round down. Ceiling's a little bit different. It says always round up to the next integer value. And that's precisely what I want here. And it's written out like this. One thing we're going to do is look at documentation, which if you're a beginner is very scary, but trust me, this thing will become your very good friend after you use it. You get used to the layout of it. This is a good reference, this C++.com. There's another one that I think is called CPPreference.com that I'll probably be in as well. But anyway, this gives you an idea. You know, I searched for this. You can see that's the name of the method that we're going to use. Important to note that we need to include this math.h header file, right? Because we're not writing the function. C++ does something nice. They have all these functions and libraries built in for us that take care of a lot of really common problems. Wouldn't that be annoying if we had to routinely come up with solutions for basic things that are used all the time? That would be so wasteful and waste so much of our time. So they have a lot of this stuff built in and we can leverage that. But the thing is if we're not implementing it, we have to bring it in, you know. And when I write this include statement to include this library, you could think of it as sort of copying and pasting in the code for this library. You can kind of think of it like that. So you can access it. It can be used without causing an error and having the computer tell you, hey, what's this seal thing? You didn't make a method called seal. So we have that now, and that should be enough to solve our challenge. We're going to round up, so like that July month 7 now, instead of being 2, it's going to get rounded up to 3, right? If even just a tiny bit over an integer value is going to round up. So consider the number 2.1. That's going to be rounded up to 3 with the ceiling function. Even 2.000000001, that's going to go up to 3 with the ceiling function. So I think this will work. We'll see if I did it right. You can run your tests first. Okay, green's good. Normally when you hit an error, You'll get some red there and hopefully some useful messages. The test runs, see this sample tests section here? It'll run all of those and make sure those check out. When you hit attempt, there's a larger collection of tests that aren't shown to you that run as well, and they're more rigorous to make sure your solution actually works. But if you want to see an error, you could comment it out, and that's a nice thing to learn too. // there will comment something out where you can keep the code in, but it's not active. You know what I mean? Think of it as like it's being turned off. And then when you want it back, you just sort of delete those. But watch what happens if I try to run without that. See, it's saying use of undeclared identifier. Some of these messages sound weird when you see them, but you could see that it's pointing at this ceiling method, like, hey buddy, what's that? So that was important. We need that. We'll put it back in. We'll run our test, then we'll run the larger attempt and make sure everything's covered. So it looks good. I like this solution a lot better. For a lot of new people who have learned the if statement, like I said, you could have done if month is equal to 1. When it says double equals, you know, checking for equality, you could say return 1. You know, that's the first quarter. And you could do this 12 times. If month equals 2, still return 1. You know, copy that for 3. But you get this long method and it looks really bad. I don't recommend that if you can avoid it. Something like this is short and sweet. I'm going to go ahead and submit that. And then there's a nice thing where after you submit, you could see what other users came up with for solutions. So it's good. I like to scroll through these and you see the way other people think. You know, it shows you other language features that you may not have been aware of. So if I hadn't seen this ceiling, I may have gone, what the heck is that seal? You'd throw that in Google and then, oh man, that's cool. That can round numbers up for me. And then you got something else in your toolbox. So yeah, here's the one. I don't like this. They used a switch statement, which is like an if else. Not a fan. But at the end of the day, you got to solve problems, right? You solve them with the way you know how to solve them, and there's something to be said for that. You get points for that. So there you have it. We will move forward to another video, and thanks for watching.